The perception of sound is the only one that we share all living creatures on Earth, plant, animal, aquatic or terrestrial.
Michel André has spent decades listening intently to the cryptic sounds coming from the world around us. He works in bioacoustics, or what he calls the science of the sound of life, using special microphones to capture the haunting calls of humpback whales swimming through the frigid waters of Antarctica, and the eerie trills of leopard seals as they glide by.
If we study this sound, we have a unique way to understand the status of health of the planet.
Human activity has seriously altered life on Earth, impacting an estimated 2/3 of marine environments and around 75% of land ecosystems. If we want to curb this loss, Michel and other researchers say it's crucial that we use our sense of sound to understand what's really going on.
And this is what drives bioacoustics. It's really to understand everything that is behind sounds. And for us, it is maybe difficult to understand because we lost, maybe not interest, but at least capacity that we had in the past to listen to the living world.
The one downside of bioacoustics, though, is that it's a slow process. Michel, who heads the Laboratory of Applied Bioacoustics at the Technical University of Barcelona, can attest to the painstaking labor involved. But consider this. A few years ago, Michel and his team were given access to a huge databank of underwater audio recordings for their whale research. The recordings were from stations that monitor nuclear activity around the world, and they run 24/7. And even though they were handed 10 years worth of data, it only took them
22 days. So we analyzed these 6 centuries continuous data in 22 days.
And that's because they were using artificial intelligence, which allowed them to go through what Michel said amounted to 600 years worth of data, or in easier terms, you could say 5.2 million hours of audio recordings in less than a month. In this episode, we're going to take a closer look at how bioacoustics could curb biodiversity loss and why Michel André says turbocharging it with the help of artificial intelligence could be fundamental for the survival of all creatures on Earth. We're also going to include a behind-the-scenes chat about the research that went into this episode, so be sure to listen to the end. This is Living Planet. I'm Kathleen Schuster. The all but untouched environment of Antarctica has been compared to a natural laboratory with rich biodiversity that's evolved and adapted to extreme conditions. This makes it a prime spot for bioacoustics research too, especially considering warmer currents and air are melting the ice at a rate of 135 billion tons a year. Michel André's research has expanded significantly over the past decade or so, from his lab in Barcelona to building a foundation in 2014 called the Sense of Silence. It's thanks to that foundation that he now has 12 yellow buoys bobbing off the shores of Antarctica. He's hoping to capture a soundscape that's been inaccessible up until now.
During winter time, of course, there is no boat, no one going there, so we don't have any data or what is going on underneath the ice. And this is something that is vital for the future, because once the ice melts, then we will have to have access to this data to be able to set this ecological corridor to protect biodiversity.
There's a small box that dangles from the bottom of each buoy. The box isn't much bigger than the length of a smartphone. As it floats below the surface of the water, its thumb-sized hydrophone, a microphone adapted to water, records the mysterious soundscape within a 100 square kilometer radius, or about 40 square miles. And Michel's listening for a number of things, like what does a healthy ecosystem sound like, or whether he can hear intruders.
Now that these temperatures are getting warmer, some species who could not access this water because they were too cold, they are slowly going there because they want to feed there. And so they are entering in competition with the species. And then through the soundscape, we can analyze the different soundscape and detect the species.
The microphones also capture the sounds of ice packs as they slide over each other. This research is still in its early stages, and what Michel's team needs are large volumes of data to train AI models with so they can get a full picture of Antarctica's marine ecosystem. Luckily, they're building on a foundation of about 10 years' worth of sporadic data recorded during various expeditions as weather allowed. But now the clock is ticking to monitor for longer stretches of time. And not just because of a warming climate. Humans are encroaching more and more on Antarctica's fragile ecosystem. Quote-unquote sustainable cruises, for example, are noisy even when their engines are turned off.
When you are on board of one of these cruise ships and they take you to this wonderful place, you are in this area where you are alone in the world, and they tell you that you cannot stay for too long because you don't want to interrupt and you don't want to be too invasive. So you only stay for a few hours. And when you leave, you really think that you have not made too much of an impact in the area. But unfortunately, if you go on the deck and you look at the plotter, which is the map where all the different activities are around, you can see that there are 100, and I counted them, of this cruise ship waiting online to do exactly what we're doing.
More than 100,000 tourists have been visiting Antarctica each year post-pandemic. That's more than double the rate in the years leading up to 2020. But why invest all of these resources just to hear odd noises and maybe noise pollution? Can these sounds really tell researchers something new that would lead to better protection of biodiversity? The short answer is yes. And early in his career, Michel found out just how powerful a tool bioacoustics can be when it comes to helping humans and other species coexist better. In the early 90s, when Michel was working on his PhD in bioacoustics, there had been a series of collisions between sperm whales and high-speed ferries in the Canary Islands, in one case killing a passenger and a whale. So a local company put some money into finding out why this was happening.
And we then needed to understand better the distribution behavior of this population of sperm whales. And for some reason that we understood a little bit later, they were right in the middle of the heaviest shipping route because this is where they were finding their food.
As it turned out, the shipping route was teeming with squid, and sperm whales eat 1 ton of squid per day. So it was no wonder that the 350 sperm whales living there had an interest in staying put. The research got going, and what was puzzling was why the sperm whales weren't moving out of the way of the boats.
So the sperm whale is the largest of the toothed whales. He's also the most ancient whale on Earth. He's been on this planet for 35 millions of years. And he has developed his brain, which is the largest brain that the Earth has ever seen. It has developed it around sound production and sound analysis.
A little refresher on whales. Whales are divided between what are known as baleen whales, like humpback whales and blue whales, and toothed whales, for example, the sperm whale. What makes toothed whales unique is, of course, their conical teeth they use to snag their prey, but also, and crucially, the fact that they see with sound. This is called echolocation or biosonar, and sperm whales use echolocation to find their food. And this is the sound they make to do that.
And with this sound, they are able to detect a squid at 3 kilometer distance, a squid of 25 centimeter long. They can communicate over 15 kilometers. Constantly, they can detect the prey, they breed, and they tell whatever story they want to tell. And this is not something that we have access to yet.
So Sperm whales are making these click sounds as they dive and swim in groups of 15, hunting for food.
So this sound that we hear is really the essence of a 35 million year of evolution around the perception of the environment in the ocean. So with one of these click and the series of click, when we hear one whale that does this is one. If we have two, we will have this, and then we heard this series of maybe 15 members of the same pod. So these clicks, these sounds, is really the history of these most ancient whales on Earth.
So why were these highly communicative whales having so much trouble avoiding the shipping traffic? If they could hear each other, surely they could hear a boat. Michel says the noise pollution caused by the ferries and other shipping traffic created a kind of acoustic smog that desensitized the whales to noise, making them less perceptive to oncoming danger. 2 of the dead whales he examined even had severe damage to the inner ear. So instead of trying to shoo the whales away with more noise, Michel's team developed a system to help warn boat captains with passive acoustics, which means
that we listen, and through the sound that we receive, we're able to triangulate and to detect the source, and then to transmit this information to the captain. So he has information where the whales are on the route.
But a key piece of information was still missing in Michel's research. What did all of those click patterns actually mean? Michel worked through months of data trying to figure out if it was just chaos or if the whales were communicating something else. And then one day, as luck would have it, a cassette tape arrived in the mail. It was from the wedding of a friend who had recently gotten married in Senegal. The music on the cassette was of traditional Senegalese drumming. And as he listened, an idea started to percolate. What if these drumming patterns were a clue?
So I contacted my friend and I said, I would like to talk to these people. And after a few months, I managed to speak to one of these drum master. And I came with my own cassette, but with sperm whale recordings. And I asked him, well, listen, I have been able to extract these sequences, and I think there is some rhythmic component in these sequences, but you are an expert. And I said, please, can you listen to this cassette?
It was only because Michel had been analyzing the data for months that he could identify the number of whales on the recording. But he had a hunch the drum master would have a better trained ear, since he was accustomed to leading up to 40 drummers at once. And within seconds, he says the drum master knew exactly how many whales he was listening to.
And then he pointed out something that I didn't know. He said, well, and this is the master. And I didn't know what he meant. And he explained what for him the master was. And in these tribes where you play drums to...
The drum master was referring to the concept of having a lead drummer with his own special drumming pattern. And then each new drummer adds a distinct rhythm and pattern to the chorus of drums. Michel says it's like a rhythmic wheel. And then suddenly, it clicked. Michel says, just like the drumming, these sperm whale clicks had what he calls a mathematical coherence. The beats and the interval of time separating them were key to communication.
So this was sort of a confirmation that we could maybe unravel some communication patterns in underwater species if we would find some help with people who use a similar approach on land.
So it wasn't just a problem that the whales had become desensitized to the noise. The fact that the noise was filling key intervals of silence in between their clicks was effectively severing their communication. That sperm whale project resulted in what was hailed as the world's first whale anti-collision system. It also opened Michel's eyes, or rather ears, to the potential of using sound to unlock key information that could protect biodiversity, for example, in Antarctica. Fast forward to present day, and Michel and his team have set up a worldwide network of 150 acoustic observatories that span several continents in collaboration with other researchers, including in the Amazon. This is another critical ecosystem for the health of the planet, which scientists warn is reaching a tipping point due to warming temperatures, drought, and an increase in logging and other human activities.
In the Amazon, there is a constant mix of sound. There is not a single moment of the day where it is silence.
Which is equally alive during the day as it is at night.
And during the night, you have all these different species, the frogs, other birds, bats, that they hunt and they look for their prey. And at the end of the night, when these night creatures go to sleep and the day species wake up and they are alive, I think that they know that they are alive because they start producing a lot of sounds as they tell, well, we made it again. We made it again. We are again alive one more day.
And thanks to their ability to use microphones both on land and in water, they've been able to help explain more about a complex food web in the Mamirawa Reserve. What's important to note is that the reserve lies between the Solimoes River and the Japura River, which are both major tributary systems that feed into the Amazon. They're also the driver behind crucial seasonal flooding that makes this reserve an important wetland. It's a region that suffered intense drought in recent years. These forests need seeds from local fruit trees in order to regenerate, and Michel's team also has figured out something new related to the complex food web that's key to this regeneration, which starts with flooding.
It will be flooded by 10 to 12 meters of water. And you have these trees that are submerged, but they are producing this fruit. All the animals have learned how to survive on these branches, so they go up and they live for 4 months.
So different species help distribute these seeds, including fish and dolphins. Yes, those are underwater recordings of fish and dolphins. And this phenomenon was already known. That is to say, local indigenous groups already knew the fruit attracted the fish. But by adding hydrophonic recordings, Michel's team was able to capture previously inaccessible data. This added to the evidence of how inextricably linked the health of the flood basin and the health of the fruit-eating fish are. Maintaining a worldwide network is not a cheap undertaking, of course, and this too will play into other international endeavors to monitor the health of the planet. Unlike a lot of research relying on government funding or transnational funding, like in the EU, Michel's foundation has also been able to secure private funding to the tune of several million euros per project.
This network allows us to be ubiquitous. And so we have, for the first time, these other sense we can hear underwater, and we have this sense that allows us to be ubiquitous. And so again, this is capacity that this technology has given us, but this is also a big responsibility, because now that we have access to all this data, we need to do something with this and not just being a witness of what is going on.
There's a lot more to say about bioacoustics research, and we're going to go behind the scenes of Living Planet with our editor and host Neil King to talk about it, right after this message.
It's tough being German. People think I'm punctual, but I'm often late.
Let's do a quick check of stereotypes.
When you think of Germany, you think of
Extreme punctuality,
perfect planning.
high-tech and efficiency.
Well, think again.
Welcome to Delayland.
A podcast about a country that needs your help.
Available wherever you get your podcasts.
Okay, so usually we just end our episodes, but this time when I was listening, I had a few more questions. So I wanted to do a behind-the-scenes chat, because while you were working on this episode, Kathleen, you talked about much more than made it into the actual episode.
That's right. Should we introduce you, by the way?
Right, okay. Well, I'm Neil King, for those who don't know. And in addition to hosting the show, I'm also the editor of the podcast.
I have no reaction to that, even though it's in the script. Okay.
Okay, but before we jump into our chat, we just want to remind listeners that we want to hear your thoughts on this episode as well. So there's a simple way to leave us a message. Just go to dw.com/livingplanet and hit record to leave us a message. The question that we have for you this week is, if you could take one of Michel André's hydrophones and drop it anywhere in the world, where would it be and why?
Okay, and just to repeat that, that's at dw.com/livingplanet. And for listeners who haven't used this record function before, it's super easy. You don't have to download anything or log in. You just hit record.
It really is super easy and fast. Anyway, so Kathleen, you ended up talking to a lot of people in bioacoustics across all sorts of ecosystems for this episode. How come, or how did Michel André end up being the main person in this episode? What made him so unique in your eyes?
Well, the challenge that I came across while I was researching bioacoustics and AI was that it's a very niche topic. And that's how one of the researchers that I spoke with described it as well. And it's gaining more traction because AI kind of makes it a bit sexier. So funders are like, oh, AI, bioacoustics. So you can see a smattering of projects here and there, and some have been going on for years. But to really find something that encapsulates all the potential of this field was quite difficult, honestly. And then I came across his project, The Sense of Silence. I think I had heard an interview with him from several years back, and he was just so interesting to listen to. And I highly encourage anybody who's interested in knowing more about him, every interview he does, he tells something new and unexpected, and he just has years and years of experience, so it's always interesting. And he was the only person that I came across who had such an extensive network of bioacoustics observatories. And then when I spoke to him, he also had such an amazing story of the research before AI became a factor. And I just thought, yeah, this would really lend itself quite well to an episode.
Kathleen, I mean, you spent a ton of time literally listening to whales, ice cracking, the Amazon waking up, plenty of fantastic sounds in that deep dive we just heard. Did you ever hear something that just, personally totally changed how you thought about biodiversity loss in a way that like numbers or pictures couldn't do?
Well, I do have one odd sound that I heard from a researcher who I spoke with named Dr. Carolyn Roston. And she's a British researcher who actually works in Norway for the Norwegian Institute for Nature Research. And we were talking about an EU project she's working on. And she just happened to mention she had this other odd sound that she wanted to share with me that wasn't directly related. But to me, it really highlighted how we know so little about the cacophony of sounds in the world and just how every living creature on this earth is adding to this music. And even if it's kind of strange. So do you want to hear it?
Yeah, absolutely.
Okay.
Wow, okay. It's like two different sounds there I can hear, right? One of them sounds almost like somebody who's asleep. A little bit of a snore.
No, it's nobody snoring. Do you want to take another guess, or should I just tell you what it is?
Is it a marine animal?
It is.
It is?
Yeah, it's something underwater.
Okay, I really don't know.
So it's a fish, and specifically it's cod.
That's cod?
Yeah, from a fjord in Norway, who was having a peaceful life until a microphone was put into his face. But yeah, so basically she randomly collected this sound on a field trip. And she was saying this was also really interesting to her because there's a whole soundscape that these researchers aren't necessarily aware of either. There are so many sounds in the world that we can't hear with our ears. We can't put our hand underwater and hear that sound. And she said, it was kind of just very lucky to collect that. And I said, okay, so what does that sound mean? And she said she thinks it had to do with protecting food. So maybe a grumpy, hangry cod. But the other thing is that she said what's already known about cod is that they make a love song. Like they sing a little love song. I don't have that,
I was just
unfortunately.
gonna say,
I'm really sorry. But I just love the idea. And I think that's what was always so fun about hearing these sounds that researchers have is for some reason they're always really interesting to listen to, even if you know the sound. So I have another one that you might be able to recognize.
Okay.
I can tell you that it's from Kenya. And I can tell you it's an animal you probably don't want to run into in the wild.
I know some fellow colleagues who can sound like that at times. No, but actually, I do know this one.
I think I do make that sound out of frustration sometimes.
No, I do know this one because, that's a hyena, right?
Yeah, it's a hyena.
Yeah.
So that came from a project that an American researcher named Dr. Astrid Strandberg-Peschken, I hope I pronounced her name correctly, sent to me. And she works for the Max Planck Institute of Animal Behavior and also for the University of Konstanz in Germany. And she's in this cooperative project in Kenya with Michigan State University. She wanted me to make sure to mention all who are involved. And what they've done is they've put collars with sensors onto hyenas. And the sensors it's a mix of GPS and audio. And what was already known about hyenas is that they can communicate with each other over several kilometers. So like up to 3 kilometers probably. But because they can track them, they could say, oh, hyena 1 did this whooping call, and then hyena 2 responded to it and started moving towards him. And so they can see much better like how far the field of communication is under which circumstances, because they're basically spying on them. And they're also using AI in their work to speed everything up, basically, to take the heavy lifting of a really slow manual analysis and also, a way that they can process hours and hours of information in their database not information, but audio in their database. And yeah, so I thought that was really fascinating. Of course, in this case, in this episode, we talked about biodiversity so much, and this is much more like behavioral. But it goes to show you the many uses that bioacoustics has, because there's information that you can take from different fields, just understanding how the ecosystem works and how animals and other species behave in the ecosystem. But I really got a kick out of that particular sound.
Just to get a sense of, how far the deductions can go when you're recording all this data. Because as you were saying, the example of just how much AI has turbocharged this, that you can process this huge amount of data in a much shorter period of time. Where are we right now in the state of, if we're looking at the bigger picture, I assume not all sounds have been mapped or recorded yet worldwide, but how far can the deductions go? Is it just a question of trying to fill all the blanks in first? Or can we already deduce that the biosphere is changing because the sounds are changing?
Well, you just asked the question that was basically the challenge of doing this research, because a lot of projects are very much in the early stages. So to your question, what I can say is when it comes to building up a database that they can use to train AI models, that's very much in the early stages, but it would depend on where you are in the world. And that's also why I mentioned in the piece the fact that Michel André, for example, is going off of many years of data. So they do have information about these environments. And then it could become, let's say with a specific project, filling in the blanks, as you put it, or being able to detect a new species that they hadn't heard before. But the other researcher who sent me that lovely cod sound, Dr. Carolyn Roston, she's working on an EU project called TABMON, which stands for the Transnational Acoustic Biodiversity Monitoring Network. And what they're trying to do is they're trying to track bird migration through Europe. And so they have sensors set up from Norway down through the Netherlands, Belgium, France, and Spain. And she was saying they're very much in the early stages of trying to figure out, how do they keep their sensors operating in extreme cold in Norway or extreme heat in Spain? How do they keep people from tampering with their equipment out in the field? But once they have all of that established, then they also have the challenge of an ecosystem, and what it sounds like in Norway is not what the ecosystem sounds like in Spain. And I have 2 clips from that if you just want to hear the difference of what they're listening to. Could you tell what country that's from? No, I'm just kidding. There's no way you can tell what country that's from. Okay, so that's France. And then the next clip.
That sounds coastal.
Yeah, and that's the Netherlands. Yeah, but as you can hear from those, you have to know the ecosystem very well to be able to analyze it. And so what I understood was, each project they're trying to build up the information that they need to answer certain questions. And in this particular case with Tabman, their first priority is just making sure that the technical side works. And so they're coming close to the end of a 3-year project. It ends in 2027. But I thought it was also such an interesting example of transnational work because biodiversity doesn't just end at a national border, of course. And especially with bird migration, this has been hugely affected by climate change with, problems arising anywhere from birds ending up at their mating sites way too early to interfering with natural pest control in the environment. If the birds aren't there when the insects are thriving, you're going to have a huge problem for your crops, that sort of thing. And with this, when I was talking to her, I said, I just kind of imagine this as like if you had a weather map where you can see the precipitation, except it's the bird migration and you just know what's going on and you can make better projections about what could happen or what we should be doing differently in the environment. And this is what she had to say to that.
Like in the 50s, they were setting out the first weather stations and they were able to start predicting the weather because they had these stations on a national scale. And that's a little bit where we're thinking also is it's becoming more and more important to both to measure, but also to predict what the consequences of this and that are on biodiversity. So we're kind of going in the same direction as the meteorologists were in the 50s.
Okay, so it can help us predict certain things. Well, that's the hope as well, right? That we can not just record data and log it, but that it can also give us something to actually prepare for a better future or help prepare for a better future. Well, I'm also wondering whether it might also be useful to discovering new species. I mean, we are discovering new species from time to time. Perhaps this would be a way to also do that.
Potentially. I mean, like he said, and the other researchers said, the huge advantage is that you're ubiquitous and you basically have your researcher in the field 24/7, no matter what the weather is, no matter what day it is. And that is the huge advantage that then you could also deduce from large scale data what seems to be normal and what seems to be different. Yeah.
I just want to come back also just to this one anecdote because I thought it was so incredible and so strong. The one about the Senegalese drumming helping decode whale clicks. I mean, that for me, it actually, that moment, it gave me goosebumps when he said, this is the master drummer. When he could hear that.
Yeah.
And I just wanted to get your take on that. When you first heard that, what was going through your mind?
Well, my first question was, did I understand him correctly? Because I don't want to tell a story the wrong way and be like the idiot journalist who didn't get it. But I mean, it was completely unexpected. And I think part of the motivation behind doing this episode was the fact that we have so many negative stories about AI, and rightly so. It uses a ton of water. It might be threatening all of our jobs. We don't know what the future holds with AI. But not all stories about AI are bad, especially if you look at certain parts of scientific research. And these aren't the only researchers I've heard this from. It's, this ability to go through an amount of data that no human could. And then when he gave that anecdote about, making this connection, I thought, is that something AI could do? Maybe. I don't know. But, that spark of human creativity, I think, is maybe the one hope that we have that AI won't get us in the end.
Yeah. It seemed to me like it could open up a communication channel. I mean, I was kind of wondering, what would, personally, I was wondering, it might be stupid, but what would happen if we played whales those drumming beats? Would they suddenly feel like, hey,
the world comes to an end.
we've got mates on land.
Okay, well, this is where we should add that a sperm whale click is 230 decibels below water. And there's a really imperfect equivalent that we didn't put into the script because sound in the water is not the same as sound on land. But I do want to mention for people who might not be thinking in terms of decibels, if we were to hear a sound like that on land, that would be as loud as a fighter jet. It's incredibly loud. So you would have to have a mechanism that could make that loud of a sound underwater. I'm just saying, Neil.
I'm sure we can get that sound system sorted. I'm just looking over to our techs.
I'll put you in touch with Michel Andre. He'd be curious, I'm sure, about your methods.
Oh, well. Kathleen, that's great stuff. Thank you. I think we're going to have to wrap up here now. It's all the time we have for this week's show. This episode of Living Planet was produced and soundscaped by Kathleen Schuster and edited by me, Neil King. And our sound engineers were Ziad Abdusleiman and Jürgen Kuhn. please tell us, what do you think of this episode? Send us a recorded voice message at dw.com/livingplanet.com. We'd really love to hear from you. You can listen to this and previous episodes of Living Planet on Apple, Spotify, YouTube, or wherever you get your podcasts. And any reviews or ratings are always very welcome. Thanks for listening, and bye for now.